We have seen system of linear inequalities in the past, and system of linear inequalities simply means you have more than one inequality that's provided to you, and we are going to find a solution that is common to all the inequalities that were given. And in most cases, we only had two inequalities, and the overlapping region was the solution. Now we're simply going to have an equation, not an inequality. Suppose let us have those two equations, x plus y equals 5, and 2x plus 3y equals 7. So those two combined together is simply a system of linear equations. Why do we call it linear? Well, even though I have written it in a weird way, you could see the two unknown variables are on the left-hand side, the numbers are on the right-hand side. When I rearrange things, if I simply had y on the left-hand side and move everything else to the right-hand side, then you will see the slope-intercept form of the line. What do I mean by that? So x plus y equals 5. If I move x to the other side, I will have minus x plus 5. Likewise, 2x plus 3y equals 7. I'm going to keep y on the left-hand side, move 2x to the other side, so negative 2x plus 7. As you can see, those are simply the slope-intercept forms of the line. So x plus y equals 5 and 2x plus 3y equals 7 are nothing but linear equations. We just have to rewrite them in order to use the calculator or to graph or anything. So, of course, there is one more step here where we want to divide both sides by 3. So y would equal to negative 2 over 3x plus 7 over 3. So great. So we have two unknown variables, and I rewrote it, and I said it's just a line. It is the slope-intercept form of the line rewritten to form a system of linear equations. And if it is a well-defined system, then there is a unique solution, or there will be a unique solution, which is simply an xy coordinate pair that will satisfy the system. Note, I didn't say satisfy an equation, I'm saying satisfy the system. So it has to satisfy both equations, otherwise whatever solution that you have is not a solution. So what would it mean for us to find the solution to a system of linear equations? Well, what we're trying to find is simply the point of intersection of the two lines. So let's just take two equations, x minus y equals 1. X plus y equals 5. I picked easy ones. So first I'm going to rewrite because I would like to graph it. So minus y would be equal to negative x plus 1. Multiply by negative on both sides. Y would be equal to x minus 1. Similarly, y would be equal to minus x plus 5. There isn't much we could do about it, so we're going to leave that as is. We can use our calculator now. So the first equation that I rewrote was y equals x minus 1. And the second equation that I rewrote is y equals minus x plus 5. And I am going to graph. So you can see the two lines intersect, and they intersect at a right angle because the two lines are perpendicular to each other. So if I hit trace, and I go to that intersection, it looks like the x value is going to be close to 3 and y value is going to be close to 2. So that point of intersection is our solution. Let's say if I get 3 for x and 2 for y as a solution. So I'm going to assume the solution is 3, 2. How am I making this assumption? I went back to the graph. The graph showed me that the point of intersection is close to 3 on the x-axis, and it is close to 2 on the y-axis, or for the y value. So I'm going to assume that the solution is 3, 2. As I mentioned earlier, if we have a unique solution, that solution must satisfy both equations in the system. What are the two equations? The first one is x minus y equals 1. The other is x plus y equals 5. So I'm going to plug in the numbers. So that is x and that is y. So I am going to have 3 minus 2. 3 minus 2 is 1. So we have 1 equals 1. It checks out. Going to go and plug 3, 2 in the second equation. X plus y equals 5. 3 plus 2 equals 5. Left-hand side is 5. Right-hand side is 5. It works out. So 3, 2 satisfies both equations, which would simply imply that 3, 2 is the solution. Here we have a system of linear equations, and we would want to verify if 2, minus 1 is a solution to this linear system. To verify if a solution or if a given coordinate pair is a solution, all we have to do is take the x and y values, plug it in the system, and see if it checks out. So I'm going to plug in 2, minus 1 in the first equation, which is x minus y equals 3. The value of x is 2. The value of y is minus 1. On the left-hand side, negative times negative 1 is positive 1. So we have 3 equals 3. That equation is satisfied. We go to the next equation. I'm going to plug in 2, minus 1. So 2 times 2 minus 4 times negative 1. 2 times 2 is 4. Negative 4 times negative 1 is positive 4. So we have 8 equals 8. That checks out as well. Since 2, minus 1 satisfies both equations, we have the correct solution. So, yes, one of the common mistakes that students tend to make is checking 2, minus or checking a given ordered pair to be a solution in only one equation. For instance, some might just check x minus y equals 3 and not check it in the other one. Good practice is to check both equations. Only then you will know if the solution is a unique solution and one that satisfies the system. So you've got to check using both equations. So the point is 4, 2. So we are going to plug in the first equation 2x minus 5y equals negative 2. So 2 times 4, because the first value is x and the second is y in the coordinate pair, minus 5 times 2. 2 times 4 is 8. Minus 5 times 2 is minus 10. So we have minus 2 equals minus 2. Now that checks out. If you stop right there, you will be making a mistake because it satisfies the first equation, but it is not going to satisfy the second equation. So 3x plus 4y equals 4. 3 multiplied by 4 plus 4 multiplied by 2 equals 4. 3 times 4 is 12. 4 times 2 is 8. 12 plus 8 is 20. And on the other side, we have 4. That cannot be true, or that is not true. So 4, 2 is not a solution. So the process in this problem is very similar to what we've been doing. So the second equation, we just have to rewrite it. We can do that when we get to it. So the first equation is 4x plus 5y equals minus 7. The first thing to do anytime you have a fraction is to have parentheses. So I'm plugging in 3/4 plus 5 times minus 2. If you use parentheses with fractions, the chances that you would go wrong is usually very, very slim. So, the 4 and the 4 will get cancelled. So you would have 3. 5 times minus 2 is minus 10. 3 times minus 10 is minus 7. Minus 7 is equal to minus 7. It checks out. If you stop right here, then you will be making a mistake. If I go to the second equation, I'm going to rewrite it in our usual form. I'm going to move the x's and the y's to one side, have the number on the other. So minus 8x minus 3y equals minus 1. Replace the x by 3/4, y by negative 2. 4 and 8 will get cancelled. So we will have minus 6. Negative 3 times negative 2 is positive 6. So 0 is equal to negative 1. That is not true. So 3/4, comma negative 2 is not a solution.